Hello, this is Mr. Wynn, and this video is about solving trig equations. It's very important. In this video, I'm going to do a talk along. Alright, to solve a trig equation, use standard algebraic techniques such as combining like terms and factoring, and our goal is to isolate the trig function involved. So for example, if we have 2 sine x equals 1, you're going to divide both sides by 2 to get sine of x equals 1/2. Then you think where on the unit circle is sine of x 1/2? You should notice it is pi over 6 and 5 pi over 6, because that's where the y is positive 1/2. Now that's on the interval from 0 to 2 pi, but sine has a period of 2 pi and there's infinitely many solutions. So you might see this, because it crosses in 1/2 infinite times. So if we don't just want the first period, we want all periods, you're going to say plus 2 pi n, plus 2 pi n. Alright, you can also think about this as a unit circle. You know, it's 1/2 right here and right here, but it's 1/2 here at pi over 6, and then every coterminal, every period, plus 2 pi to get the same spot, coterminal angles. Alright, so same for this one. You go pi over 6 and add 2 pi more, then add 2 pi more, but you still get 1/2. Alright, so write your answers using exact values rather than decimal approximations like normal. But sometimes we want the answer within one period from 0 to 2 pi. Sometimes we want all possible answers, where you say the general solution where you play plus 2 pi n if you're doing sine or cosine, because that's the period. If you're doing a tangent, you add pi n, and we'll see what happens later. Alright, so here's the problem. Solve sine of x plus root 2 equals negative sine of x. So one, you move the sine x over by adding it. Then here I'd combine like terms, but they chose to subtract the root 2. That's okay. Then they chose to combine like terms, and then you divide 2. So no matter what, you should have got here. However, you solve for sine of x. Then you think where in the unit circle is sine x negative root 2 over 2. If we're between 0 and 2 pi, then we get 5 pi over 4 and 7 pi over 4, because that's where sine is negative. But if we want all possible solutions, we're going to add multiples of 2 pi n. Alright, here's another one. So first, I'm going to solve for tangent of x. I'm going to add 1 to both sides. Divide both sides by 3. Then I'm going to square root both sides. Then you have to rationalize. Alright, so plus or minus root 3 over 3. Make sure you have a plus or minus sign when you square rooting. Now tangent has a period of pi. So between 0 and pi, where is it positive root 3 over 3 and negative root 3 over 3? Well, that's pi over 6 and 5 pi over 6. Then we add periods to them, a full pi, to get all solutions possible, the general solution. Here's another one. So we're going to move everything to one side. We're going to factor out cotangent, so that's GCF. Then we do the zero product part. We set each product equals 0. So the first thing equals 0, cotangent x equals 0, and the second thing, co squared x minus 2 equals 0. Cotangent x is 0. That's easy, pi over 2. Remember that's a over o. X over y, so where is it 0? X has to be 0, y has to be 1, so that's the top pi over 2 of the unit circle. Here we're going to add 2 both sides, then square root both sides to get plus or minus square root 2. So where I found that, pi over 2. But the second one, where's cosine positive root 2 or negative root 2? Now root 2 is actually 1.4, so where's cosine 1.4? That's not on the unit circle. That's outside the range, because cosine has a max of 1 and min of negative 1. It's the range between negative 1 and positive 1. Closed. So that one is extraneous solutions, or it doesn't work. Alright, so our only answer is pi over 2 plus pi n. Because that's the tangent, cotangent. Both have a period of pi. Alright, here's the next one. So we can factor, guess and check. So what times what's 2 sine x, sine squared x, so it's 2 sine x times sine x. What times what's 1 is 1 and 1. You do the signs to check o and I. Then you set each factor equal to 0. Subtract 1 divided by 2. Add 1. Where sine of x negative 1/2, that's 7 pi over 6, 11 pi over 6. Where sine of x 1, that's just the very top, pi over 2. Now this one always says interval 0 to pi. If I want all solutions, I'd add plus 2 pi into all three of these really. Here's the next one. Here it has sine and cosine, so you want to try to make it have just one of them. So we're going to use the Pythagorean identity, sine squared x equals 1 minus cos squared x. So we replace sine squared x, you distribute, and then combine like terms, then you factor, guess and check. Set those each equal to 0. So we get those two equations, add 1 divided by 2, or here just add 1. Where's cosine 1/2 x equals 1/2? That's pi over 3, 5 pi over 3. Where's cosine 1? It's when x is 0. That's for 0 to 2 pi. And since they didn't say on the single period 0 to 2 pi, we have to find the general solution, all solutions. So we're going to add 2 pi in to all of them, to 1, 2, 3, all three solutions. Alright, here's the next one. This one's kind of weird. Cos x plus 1 equals sine x. Now, we can't use identity to make it all cosine or all sine. So we're going to square both sides. So when I square the left side, I have to FOIL. I get cos squared plus 2x, 2 cos plus 1. And I square the right side, I get a sine squared x. Then we're going to do the pattern down the right side. Sine squared x turns to 1 minus cos squared x. But now everything's cosine. That's good. Alright, so squaring both sides is a technique. Moving to one side, combine like terms, factor, GCF, 2 cos x, 0 product property, set each equal to 0. This one divide by 2. This one subtract 1. Cos x is 0 at pi over 2, 3 pi over 2. Cos x is negative 1 at pi. Now, this looks like there's 3 answers, but because we squared both sides, we have to check for extraneous solutions. We'll check all 3 answers. The first check, if I plug in pi over 2, cosine of pi over 2 is 0, plus 1 is equals sine of pi over 2, well, that's 1. 1 equals 1, that's good. I check 3 pi over 2, cosine of 3 pi over 2 is 0, sine of 3 over 2 is negative 1, is 1 equal to negative 1, that's false, does not check, so that's extraneous. Then I check pi, cosine of pi is negative 1, sine of pi is 0, negative 1 plus 1 is 0, 0 equals 0, that's true. So of the 3, only 3 pi over 2 is extraneous, so we ignore that. So if you want to say between the interval 0 to 2 pi, like I said, there's only 2 answers, pi over 2 and pi. Here's another one, so we're going to add 1, divide by 2. Now we have cosine of 3t equals 1/2. Now we're used to cosine of x or cosine of t is 1/2, but we're going to do the same idea. So where is cosine of x 1/2? It's going to be at pi over 3 and 5 pi over 3. But we're not talking about cosine, we're talking about 3 of x, we're talking about 3x or 3t in this case. So we're going to say 3t equals that, and then 3t equals that, with the general solution, then just divide both by 3. So here's our answer, and the period's now changed, because that's the b value. So really it's 2 pi over 3 now, instead of 2 pi. Here's another one. Subtract 3, divide by 3. Where's tangent of whatever negative 1? So it's the pi over 4s, but it has to be one positive, one negative. So quadrant 2 and quadrant 4. Alright, so let's see. Yep, that's quadrant 2 from 0 to pi. Alright, so we know x over 2 is equal to that because it's not just x, and tangent is pi. You times both sides by 2 to get rid of the fraction, and you get this. And this automatically takes care of the one in the fourth quadrant as well. Alright, here's another one. So we're going to subtract, I guess they chose the Pythagorean identity, change secant squared x to 1 plus tan squared. And they moved the 4 by subtracting it. Combine like terms, guess and check, factoring. Set equal to 0, set equal to 0. Alright, add 3, subtract 1. Where's tangent negative 1? Well, that's negative pi over 4. Now where's tangent 3? Now 3 is not a nice thing on our unit circle. So we have to do tan inverse both sides, arctan both sides. So here it says recall the range of inverse tan. Arctan is negative pi over 2 to pi over 2. That is an angle, just we don't know what it is. So those are 2 answers. We want all general solutions. We're going to add pi into both of them. And if you really wanted to, you could type in arctan 3 in the calculator to see the decimal, or whatever that is. Alright, here's 6 more with the pictures. So you're going to add 1, divide by 2. So where's cosine x 1/2? If you look on a picture, x is positive 1/2 right here and right here, right? So it's going to be pi over 3, 5 pi over 3 if you want 0 to pi. If you want all answers, you're just going to add 2 pi n to both. Here's another one. You're going to subtract tan squared x, add 1, divide by 3, square roots. Alright, so where's tangent of x plus or minus root 3 over 3? There's 4 spots. Alright, so if you want from 0 to 2 pi, write all 4. Then, if you want all of them, you have to add pi n. Now, technically, these first 2 plus pi n takes care of everything, because tangent has a period of pi. Here's another one. Let's change secant to 1 over cosine, tangent to sine or cosine, common denominator, make it a single fraction. Remember, there are restrictions when there's x or variable on bottom, so cosine x cannot be 0. So x is not allowed to be pi over 2 or 3 pi over 2. So sometimes those do show up. Alright, I multiply both sides of cosine to get this fraction. 1 minus 2 sine x equals 0. You can subtract 1, divide negative 2. Sine of x is positive 1/2. Where's sine of x is positive 1/2? It's right there and there. And remember, these are restrictions. Alright, so if you want, that's for, well, if you want the entire general solution, you're going to add 2 pi n to both of those. If you just want from 0 to pi, just pi over 6 and 5 pi over 6. Here's another one. Make them, this one cosine over sine. You do common denominator, but they chose to factor out cosine, which is fine. 0 product property. Well, actually, we don't say this. Sine can't be 0, because that's in the bottom of the fraction. So cos of 0, x is 0, that's easy. Pi over 2, 3 pi over 2, if you think about this. 1 minus 1 sine x is that. The added sine x multiplied by the fraction, or sine x go to the fraction. Sine of x is 1 at pi over 2. Alright, so pi over 2, pi over 2, 3 pi over 2. And if you want all solutions, it's pi over 2 plus pi n. Because pi over 2 plus pi n is 3 pi over 2 plus pi over 2 is 5 pi over 2 right here, right? And it keeps going in these 2 points. This one, subtract 3, guess and check. So factoring, z equals 0. Subtract 1, divide by 2, add 3. Look on the unit circle, where's sine of x negative 1/2? It's down here. So that is 7 pi over 6, 11 pi over 6. Where's sine 3, sine of x 3? Remember, sine only goes from negative 1 to positive 1, so this is impossible. That's extraneous. Alright, so if you want all solutions on the general solution, say 7 pi over 6 plus 2 pi n, because the period of sine is 2 pi. Then same thing over here for 11 pi over 6. And you say 2 pi n or 2n pi, same thing. Alright, this one, add root 2, divide by 2. So where's cosine root 2 over 2? It's right here at pi over 4, and here 7 pi over 4. But that's, instead of x, we have 2x. So 2x equals that, 2x equals that. Divide both sides by 2, you get those things. And that's our solution. If they want from 0 to 2 pi, just plug in 0 for n, 1 for n. So pi over 8, 9 pi over 8, that's 7 pi over 8, and 15 pi over 8, that's still under 2 pi. Alright, that's it for the video. Make sure you ask any questions. Make sure you join the live session where I do a lot of these. Thanks for watching. See you soon. Bye.